Hello again. This is Math 2115 coming from the College YouTube page, and the title of this lecture is The Completion of the Fibonacci Discussion. As always, please be attentive while watching this video. As you may recall, we were solving for the second order recurrence relationship for the Fibonacci sequence. And the crux of the issue at the end of class was we were solving for the coefficients C and D in this formula. And this was a formula that we had derived. And we started by considering the recurrence relationship AN is equal to AN minus 1 plus AN minus 2. In this case, rise to the characteristic polynomial t squared minus t minus 1 equals 0, which has roots of 1 plus root 5 all over 2 and 1 minus root 5 all over 2. And so we then formed this linear combination to figure out what the coefficients would be. But the problem that we were having was one of the initial conditions. You see, the Fibonacci sequence starts at 0, and again, this is 0 exclamation point, not 0 factorial. And so the Fibonacci sequence is known to be 0, 1, 1, 2, 3, and so on. And so the recursion relationship, we had to substitute those initial conditions of a 0 equaling 0 and a 1 equaling 1 into our equation. Now here I've repeated the formula for you so we can just reference it. So when n is equal to 0, we got something raised to the 0 power here and something else raised to the 0 power here. Neither one of them are 0, so they're both 1. And setting that equal to a 0, which is 0, we get c plus d is equal to 0, meaning c is the negative of d. Now we move on to taking n equal 1, and that means a1 is equal to 1, so we put a 1 here, and we place n in these equations by 1. Now, and we're also going to substitute that c, the coefficient here actually is the negative of d. So you see when we put the negative of d here, what will happen is that negative 1/2 d will cancel with positive 1/2 d, but then we'll have negative root 5 over 2, and we'll also have another negative root 5 over 2, and so that will be negative root 5 times d. So that's equal to 1, and that means that d is equal to minus 1 over root 5, and that tells me that c is 1 over root 5. This means we have derived the identical formula that we proved by induction earlier in our course, namely that a sub n for the Fibonacci sequence is 1 over root 5 times 1 plus root 5 over 2 whole to the n minus 1 minus root 5 over 2 to the n. In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself because self-care is important. And now more than ever, take care of each other because we're all in this together. Strive to make a difference. God bless you all, and I will look forward to seeing you in class.